Okay, for homework 923, I'm going to have you fill in these numbers, show me the work, and then turn this in tomorrow with the 3 words to show me that you listen. All right, so here we go. This graph one, writing recursive and explicit. I'm going to have you put your first coordinate for this one right here at this spot. That is the coordinate, really 1 for x, up 1, 2, 3, 4 for y. Then I'm going to have you from there go over 1, up 2 boxes. That next coordinate is really over 2 for x, up 1, 2, 3, 4, 5, 6 for y. Then from there, over 1, up 2 again. Or you could go over 3 for x, 3 boxes to the right for x, and then up 1, 2, 3, 4, 5, 6, 7, 8 for y, or f of x. Then over 1, up 2 again. You need to be good at that practice of looking at these grids and going that precision. Over 1, up 2, over 1, up 2. Precision matters. That very first coordinate, that is the first term. With all that, you could start filling all of this. This is x. This is f of x, which is really the y coordinate. This is 1, 2, 3, 4, 5, or term, first term, second term, 0 term. This here are your y numbers, or f of x numbers. That very first coordinate right there is technically the coordinate 1 for x and 4 for y, or f of x. If I reverse that pattern, and instead of going right 1, up 2, right 1, up 2, right 1, up 2, I could reverse that pattern and go down 2, left 1. And what that does is that nails that y-intercept coordinate right there. Still on that same line that we're drawing, nice straight line arithmetic. That coordinate right there is the coordinate 0 for x, 2 for y, or f of x. With this function notation, I have this right now. I have that the 0 term is positive 2 on my y-axis. I have the first term is 4 on the y-axis. Those are those coordinates. If I look at it, my rate of change as I'm going over 1, up 2, over 1, up 2 for this one, if I put that together, that is your slope, that is your rate of change, that is your m, that is your d. We're going to use that for d for this instead of using that for the letter m. That is my slope, 2, positive 2, going over 1, up 2. If I write recursive, plus for this one, 2. If I wrote what the 0 term is, or the first term at least, that would be 4 right there. Or if I did that color coordinated, so that's the kind of answer we're looking for. If I'm doing explicit, a little bit harder, I'm putting that positive 2 right in front of x. That slope number, that d number, always goes in front of x. And then the other number is the y-intercept term number. So that positive 2 right there. Or when x is 0, y is 2. If I shift over 1 to the right to use that first term instead, I'm still going to use 2, but it's going to be x minus 1 plus that 0 term, that first term. The first word is island. Island. Please don't share these words. If you are taking the time to listen, don't share these words. And then you need to know that these two, even though they look different, they are technically the same. They are equivalent. They are the same, but in disguise. If I was to distribute that 2 right there, that would give me 2x minus 2 And then that 4 and that negative 2 right there, they combined to give me 2x plus 2, the same as over here. So you can see any number I plug in for x will always give me the same answer for y, or f of x. All right, next one. It's going to be geometric, starting with 1. Then we're going to go to, let's go 6, and then 36 for this one. All right, so obviously not going up by the same amount each time, not linear, not arithmetic straight line. This one, geometric, going up by a little and then shooting up a lot. So this one I could see timesing by 6 makes this geometric, makes this one, instead of a straight line either being positive slope or a straight line with a negative slope, these are going to be exponential. And then, of course, there are these negative exponentials that go down. All right, so for this one, I need to know that this is the first term, second term, third term. What I know already is that 1, I get 1 right there. I'm going to need the 0 term on this one. So if I'm going to the left, I'm dividing by 6, or we're going to write that as timesing by 1/6, because remember, timesing by the reciprocal of 6 is dividing by 6. 36 times 1/6 is 36 over 6, which is 6, or 36 times 1/6 is 36 divided by 6. 6 times 1/6 is 6 over 6, which is 1, or 6 divided by 6 is 1. Positive 1 right there times 1/6 is 1 times 1/6, and then structurally, remember, put that whole number over 1, and you times the numerators, you time the 1/6. So as I go to the left, that 1 times 1/6, which is going to backtrack and give me this 0 term, that gives me the all-important y-intercept number, 1/6. If I was to keep backtracking to the negative 1 term, that 1/6 times another 1/6 will give me 1/36. You can see why these values get small. If I was to go to the negative 2 term, that 1/36, 6 times 36, I'm not quite sure. We'll leave that alone. All right, so I know that the 0 term is 1/6. I know that for this one, I don't use the letter D because it's not arithmetic. I'm not adding, subtracting by the same amount. This one I'm timesing, so we use what we call the letter R for this one. So for recursive, it's going to be f of x. And again, remember, that's nothing more than to find the next term, use the 1 before it. And for this one, times by 6. Different than the adding one over there to the left. And of course, the first term, once you list it, is 1. If I'm doing explicit, a little harder, I could use that 0 term times the R number to the x power. Or I could use, shift over 1 to the right, I could use that first term, which is that 1 right there, but times that same 6 to the x minus 1. And we're going to practice using these formulas more next week. But on test day, you just got to list them. And then, of course, yeah, we'll leave it like that. For explicit, I'm not going to write the first term. That's always going to be just for recursive. The second word is Michigan. Michigan. All right, last 2 problems of your first test. Here we go. This one. I'm going to make this 3. Going to make this 9. Going to make this 27. Looks like going up by a little and a lot geometric timesing. This one over here is going to be a word problem, and it's not going to have a percent in it, which means it's going to be arithmetic, and we'll be talking about that. So if you could fill in these numbers. So again, any of these word problems, if you don't see a percent in there, arithmetic. If there were any word in there like 3%, as soon as you see a percent in there, that's a timesing geometric. No percent in this, arithmetic. Watch. All right, so for the table first, this one, timesing by 3, makes this geometric. I could see that I'm going to have to backtrack a lot. I'm going to have to go to the 4, the 3, the 2, the 1, and then the all-important 0. So what I'm doing to backtrack, I'm using this number right here, and I'm doing the opposite of timesing by 3, going up the column, which is dividing by 3. But remember, we're not going to show dividing by 3, even though that's really what we're doing. 27 divided by 3 is 9. 9 divided by 3 is 3. We're going to show dividing by 3 as timesing by the reciprocal of 3. Or taking 3 and flip-flopping it so it's 1 over. That's what reciprocal means. So times by 1/3. And then what number am I timesing by 1/3? That 3 right there. 3 times 1/3 structurally is 3 over 3, which is 1. Or 3 divided by 3 is 1. So that first number is 1 for the fourth term. 1 times 1/3, if you remember, straight 1/3. So that 1 times 1/3 gives me for the third term 1/3. 1/3 times another third, straight across 1/9. So that second term is going to be 1/9. And then as I go further, 1/9 times 1/3, 1/27. Notice I'm only timesing the bottom number by 3 each time. That top number stays the same as these numbers get into fraction land. And then 27 times 3 gives me 81. So that 0 term is 1 over 81. And I got that by just taking these numbers. 3 times 1/3, 1. 1 times 1/3, 1/3. 1/3 times 1/3, 1/9. 1/9 times 1/3, 1/27. Times 1/3, 1/81. You need to come to grips with these fractions on these geometrics. All right, so I need to know these two things. The 0 term for this one, 1/81. The first term for this one, 1/27. The R number for this, because this is geometric, not a adding one, is 3. So as I write these equations, here I go. Recursive. Times 3. And then of course, we usually write that first term. So if someone had to write this sequence out, they would know what to write and where to start. Start with 1/27. And then keep timesing by 3. That makes that 1/9. All right. For geometric, here we go. For explicit, I could either use that first term, 1/81, times 3 to the x, or I could shift over 1 to the right and use that first term, 1/27, times 3 to the x minus 1. Let's just double check my work. So fifth term 3, fourth term 1, third term 1/3, second term 1/9, first term 1/27, 0 term 1/81. Looks pretty good. All right, so a lot of fractions. This one is arithmetic. Putting money in the bank is not going to be timesing. It's not a percent. There's no percent in here. So that means that initial deposit, that putting $15 in the bank, that is your 0 term, or how much money you have even before anything started. that $5 that you're depositing there is being added to that. That's going to be your D number right there. This is arithmetic. If I add that 5 to that 15, that will give me the first term right there. So this is a little bit more complicated. So if I have that 0 term 15, maybe some of you might want to write it like this. And then you got your first week, second week, third week, fourth week, fifth week. After 1 week, I'm depositing $5. That is my D number. So if I take that 15 and I add 5, that gives me how much now is in the bank after the deposit, which was money already in there. But now after my very first deposit, or after Shannon's first deposit, 20. And then as she adds another 5 right there, that of course keeps the pattern going. 25 plus another 5, 30. Those of you who've been with me, you can see that this is going to be a straight linear line starting at really 0, 15 on the y-axis, going over 1, up 5 each time, over 1, up 5, over 1, up 5, straight line linear, starting with 0, 15, and then going up by 1 for x, but then 5 for y, 120, 225. That's what this line, that's the situation is showing you. So for this, first term is 20. The D number is 5. This is arithmetic word problem. We'll be practicing this before Friday, I promise. Recursive. Plus that D number. Explicit, using first term and 0 term. This is not geometrics. Don't use the exponential one. This is where I put that adding number, the depositing each time number in front of x, plus the y-intercept number, or how much was in the bank before this whole situation started. Or of course, you need to be able to go over to the right one using that same 5 number, which I'm adding each time I deposit, adding that first term number right there, which is 20, knowing that these are equivalent. 5x minus 5 plus 20, that is equivalent right there. And then back to this recursive one. Recursive, always get in the habit of writing either the 0 term or the first term, so someone knowing how to write that sequence out would know what to do. All right, so that's your homework for tonight. Due tomorrow, the third word is Drummond. Drummond. Good luck.